Welcome to The Explainer. So glad you're here. If you're a focused learner looking to really level up those programming skills, you're exactly in the right spot. Today, we're setting the stage for a totally hands-on exploration of Python's core architecture. We're going to take those abstract concepts of classes and objects and bring them right down to earth so you can actually use them to build some incredible things. Let's get right into it. Have you ever wondered how Python actually manages really complex architecture? I mean, imagine trying to build a massive towering skyscraper. But there's a catch. You have zero master plan. You just have a huge pile of steel, some concrete, and like 100 workers trying to figure it out on the fly. What happens? Absolute disaster, right? In programming, we literally call that spaghetti code. It's tangled, it's totally confusing, and if you try to pull just one string, the whole building comes crashing down. So how do the pros avoid this? How do they build complex, sturdy software? Well, they use a very specific architectural system, and that is exactly what we're going to master today. Okay, real quick, here's our roadmap. We'll hit core architecture, look at blueprints, which are our classes, move into construction for our objects, dive into a hands-on coding tutorial, and wrap up with why this architecture actually matters. Jumping right into section 1, core architecture, otherwise known as object-oriented programming. Object-oriented programming, or OOP, is basically the ultimate fix for keeping our code sane. For a long time, early programming was literally just a top-down list of instructions. Do this, then do that, then do this other thing. But OOP completely shifts that paradigm. It organizes your software design around data, or objects. Think of it like breaking your code down into distinct, self-contained modules that actually interact with each other, instead of just one giant, impossible-to-read script. It really is the absolute foundation of modern Python. Moving right along to Section 2, Blueprints and Defining Python Classes. Let's step into the Architect Studio. This perfectly illustrates the fundamental difference between the two terms you're going to hear nonstop: classes and objects. A class, that's just the blueprint. It's totally theoretical. It tells you exactly where the walls go, how many doors there are, but you can't physically live inside a piece of paper, right? The object, on the other hand, is the actual physical house that gets built from that blueprint. It's got real wood, real glass, and you can literally walk right through the front door. So the real trick here is just memorizing this little translation dictionary. It lets you map these physical, real-world concepts straight to Python jargon. When an architect says blueprint, a Python dev says class. When the architect says house, we say object. Now the features of that house, its color, the number of floors, those are called attributes. And the actions a house can perform, like opening the garage or locking the windows, we call those methods. Honestly, if you can just lock in those 4 pairs, you've pretty much conquered the hardest part of OP.
Which brings us to Section 3, construction, and actually building Python objects.
Let's look at how these objects actually behave. Every single object is built directly from a class blueprint. But here is the absolute magic of the system. From one single blueprint, you can construct literally hundreds of unique objects. You could build a whole suburban neighborhood from one set of plans. Each object, each house, will contain its own specific attributes, so maybe house A has 4 windows, but house B has 10. And each object can perform its own methods completely independently, like opening its own front door without magically opening the doors of every neighbor's house. They share the exact same structural DNA, but they are completely individual entities. All right, Section 4, Hands-on Coding Tutorial. Time to actually draft and construct. Grab your hard hats, we are heading to the workshop to walk through the real syntax here. There are just 3 fundamental steps in our assembly line. First, we write the class keyword. Second, we define the special init method to set up our features. And third, we instantiate the object, which is really just a fancy way of saying we build the thing. Let's check out each step in action. Step 1, in your editor, you literally just type class house. Typing that word class is the exact equivalent of unrolling a big blank sheet of blue paper right on your drafting table. You're telling Python, hey, get ready. I'm about to define the rules for a brand new type of structure. And notice that capital H in house? That's actually a best practice in Python to make your blueprints really stand out from your regular variables. Okay, step 2. Indented right underneath that, you define your initialization method. You type def __ nit __ self, colon. This init method is basically your baseline specs. It sets up the mandatory features your house absolutely must have before it's even allowed to be built. In this case, we're saying that whenever a house is constructed, someone has to specify how many windows it has. Oh, and that word self, that's just Python's clever way of making sure the house remembers its own specific features later on. And step 3. You step outside of the blueprint itself, and you type my house equals house, windows equals 4. What's really wild about this single line of code is that it acts as your actual construction crew. The split-second Python reads this line, it pulls up the house blueprint, sees that it requires a number of windows, grabs the number 4 you gave it, and physically allocates computer memory to build this object. Boom. You now have a working, fully functioning object named my_house living right inside your program.
Finally, section 5, why this architecture matters. Let's look at the big takeaway.
Let's zoom out from the code for a second. Why does this class-to-object relationship make you such a better programmer? Well, adopting this gives you massive benefits. First off, like we talked about earlier, it totally eliminates that messy spaghetti code. Everything is neatly organized. Second, blueprints are endlessly reusable. If you're coding a video game and need 1,000 enemy spaceships, you don't write the code 1,000 times. You write the spaceship class exactly once and just instantiate it 1,000 times. And lastly, maintenance is a total breeze. If you find a flaw in the plumbing, you don't break into 1,000 individual houses to fix it. You just update the central blueprint once, and all the future houses are built perfectly. It saves time, crushes bugs, and lets you build incredibly complex virtual worlds so easily. So the foundation is laid, the structure is built, you know the exact difference between a class blueprint and an object building, and you've got the syntax to draft them yourself. So I'll leave you with this. What physical system are you going to architect in Python next? Is it going to be a bank account, a shopping cart, maybe a self-driving car algorithm? Take this tutorial, crack open your code editor, and start drafting your own blueprints today. Thanks so much for joining me on this explainer, and happy coding.